Sound test. Something doesn't work on YouTube. Why is that? Am I not live on YouTube? Oh, I see. I'm live with the same settings as yesterday, which is fine. But surprising. Sorry about this. Apparently I created a new event in YouTube, but still I'm streaming to that old event. All right, here's the plan for today. The plan is first, make the plan. Second is I will play Wordle once to show you the rules. So show Wordle again. 3, summary from yesterday, what my algorithm already does. 4, refactoring. 5, it will be testing. I want to make sure that my algorithm is correct. So I will try for much smaller dictionaries, compare it with a brute force without any pruning to make sure that the answer is the same. 6, printing something, maybe, well, some more optimization. 7 will be printing statistics, anything like that. Also actually using this algorithm to tell us what are good first moves to make. Something like that. And the most important part is, of course, making it faster to actually make it work for the full dictionary of size 12,000. Graph plan. I don't have any ideas what to implement about a graph. Wait, we have a live chat on YouTube today. We'll see how it goes. I think Restream changed my settings. I'm not going to read chat that much. Okay. The plan is done. So now let's move to Wordle. If you don't know this game, you can try 5-character words like crane, and then it will tell you what is the feedback, and it means that apparently on 2nd, 3rd and 5th position the characters are exactly right. What are other words? Let's say ghost, something completely different. I didn't hit anything. The word from yesterday was elder. Now yellow means that E appears somewhere in the hidden word, but not here. So we're looking for basically a word that matches 2nd R, 3rd A, 5th E. You can try it yourself, link in the description and in the chat. Yeah, I would now here. Before I continue, maybe let's try to ask a program. I will get back to this game once I modify my program a little bit to actually tell me what should be the next move. Also, I've run this thing yesterday, the program from yesterday, for dictionary of size almost 2000, and it took 80 minutes and 2/3 of a gigabyte. And I'm still estimating that the full thing for a dictionary of size 12,000 will take a few years. The time complexity isn't really the best. Okay, show Wordle summary from yesterday. Let's talk about this program I did yesterday during a live stream. This is a related drawing. Everything is okay with the chat? The YouTube settings aren't as I expected, but maybe it's fine. So we have a dictionary of size. Dictionary size is around 12,000. Yes, I know. Why can't I close this? There is dictionary of size 12,000 or so. Come on. That's annoying. And we make a first guess. There are the possibilities. I consider all of them. I cannot skip anything. So I consider that maybe first I will try abaca, which maybe is the first word in dictionary. I don't think so, but I try each of them. I think about it as recursion, as DFS through the tree of all states. Then after I ask about abaca, I get possible feedbacks. If I get, for example, black, 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 so all the characters are missed, then I have some remaining dictionary of possible words. I can here say what is this dictionary of possible words. It will be smaller than 12,000, obviously. And once again, I choose a word to ask about, for example, crane. And I go through all 12,000 words. For each of them, I then iterate over what is possible feedback, and depending on that, what is the set of remaining words that are possible. Now, the time complexity is limited, well, by 12,000 to some power, because at every layer of this tree with recursion, we have all of the possibilities of what we choose. Then also the feedback is limited by what the hidden word is, and hidden word is one of 12,000 words. Yep, so we can kind of estimate it as d to 7th power, I believe, because we make 6 guesses. It's about the number of leaves in this huge tree, because we recurse this whole tree, we traverse it. The time complexity is around that, which is of course way too much for 12,000. Some states are impossible. Also, d to 7th is because I'm making guesses, and the feedback is decided by this hidden word. So in total, there are only 12,000 possible sets of feedback for my guesses. So every leaf of this tree is described by my 6 guesses and the hidden word. Okay, now what did I do to make the program slightly faster? I'm optimizing for the average number of guesses, the expected value of the number of guesses made by this program if we start with a random hidden word. To measure that, I try all the possible hidden words, and depending on that, I see what my program does, and I take the average out of the number of guesses for such a strategy. Any strategy could be verified like that. And yeah, so I optimize for that, the expected number of guesses, the average number. I lost my thought here. What was I saying? Oh, how can I do this faster? I did some pruning, just like you do in, like, for example, there is alpha-beta pruning in 2-player games, or there is A-star algorithm for pathfinding, which works well, let's say, in a grid if the grid isn't very, very complicated. where I started by asking very common words like crane. So first I consider maybe my first guess should be crane. Then based on that I compute the answer. Let's say the answer turns out to be 4.2. Then when I consider the next word, let's say grape, when I keep going through this tree to verify what's the expected value here, if I consider some part of this tree already, and the expected value already sums up to 4.2, let's say 4.21, then I don't need to finish, I don't need to analyze the rest of this tree exactly, because I already see that the possibilities considered sum up to more than 4.2. So I'm not going to finish exact computation of expected value for this subtree, because grape isn't optimal, I already see it. It's a bit like saying that depending on the starting word, I will have some score, and for crane, I already know that the score is 4.2, and now I'm computing it for grape, and for few possibilities already I get 0.5 plus 2.2, depending on what happens in the next step, plus 1 plus 1.5 and so on. And if this sums up to what, 3.7, I think 5.9, no, 5.2. This is already greater than 5.2, so even if this sum is longer and I could continue computations, I don't need that. I already see that this is not optimal, so I will never know. My algorithm is supposed to find the optimal strategy, in particular the best starting word, and then the best second word depending on the feedback and so on. But I'm not going to know the exact score for every starting word, because for many of them I will quickly decide this cannot be optimal because this sum already exceeds the value allowed, the best value so far. So I did this kind of pruning. I considered words sorted by the frequency of characters. So for example, crane is, or grape or something like that should be early because of characters. A, E, R, S, T, those are common characters. While something like gummy is a word with uncommon characters and very unusual structure, so this will be considered close to last. Because it is most likely a bad guess. So that was point 3, summary from yesterday. I'm reading the chat now. So is it okay on YouTube? Yeah. All the messages are now copied between Twitch and YouTube. I will turn it off next time. I don't think it's that important for YouTube chat to exist at all. But for now, let it stay. Next step, refactoring. I'm going to take my code from yesterday and just remove unnecessary parts and make it nicer, maybe also faster thanks to it. So let's do this refactoring. Later I will go back to this puzzle. To make sure that I'm not messing things up, let me run it for smaller part of dictionary. This should be 5 seconds. And the answer given here should be the same after my refactoring. Most commonly used letters of English alphabet are this. Can this be used? Yes, I automatically use it. I don't need to hardcode the common characters. I use the dictionary, so I automatically compute the frequency of characters. And that happens somewhere in here, get frequency. And here compute frequencies. Later I will make it into a function. But those 3 lines, they iterate over all strings in dictionary, and for all characters of that string, it counts the frequency. And after that, we can even print that. For everything in char frequency. A appears 240 times, E appears 283 times. Later on I sort something by those frequencies, or by the sum of frequencies. But X is a very uncommon character, Z is a very uncommon character. Whoa, that's surprising. I didn't know that Z is that uncommon. I wouldn't guess that. S and T should be. Well, P isn't that common. R, S, T are nice. Osakobus, are you asking about something related to the stream? Not finding time. Well, I will not help you about your work-life balance. Sorry. Let's start from the top. And I will... Let's remember this thing. So in particular, the number of saved and the... I will put this at the top. After I refactor my code, it should still print this for 0.25 dictionary size. All right, we read the dictionary. I have two dictionary files. In this one, there is this annoying part with double quotes where I need to read it in a different way. I'm going to just replace it. Where is search, replace? That's first, then this. Okay, now it's a nice list of words. Control S, then this is another list of words. One of them is 2300 words, the other is 12,000. Maybe it would be nice after reading, not saying how much dictionary percentage I use, because that depends on the file, but what is dictionary size? So let's print dictionary size. That's just that size. I don't care about that. Dictionary ratio here is at the top. It's what percentage of the dictionary I take. It was convenient to play around with this value. Random shuffle, so I don't need this anymore. Don't need this. Okay, reading is fine. Maybe later I will read from the standard input to conveniently redirect and choose from which file I want to take the data, but that's fine. Sort the guesses by how large the largest possible remaining number of words is. Yeah, so what you're suggesting, Nicola, is a reasonable strategy, but there is no reason for it to be optimal. Whether I should consider things in this order, well, it would require us to first try every guess and then sort according to that and only then go recursively further, which I can do that. I will write it down at the top as an idea. Idea. Consider all guesses. Check group sizes. Only then go recursive. It would just give us better pruning. Okay, there is reading. Now there's info. I don't store info in this array format anymore. Let me get rid of all of that and see what I actually need. Oh, everything compiled. Really? Well. Because info is just partially used here. But I have this printing of a guess. How should I go about it? Maybe let's not have struct info anymore, because now I anyway use int. But what I want is still printing for debugging purposes. Print of info, or more like feedback, and guess. Int guess or string guess. String guess is better. Okay, now how do I match here? Modulo 3 will be the last value. AI's feedback modulo 3. Okay, and now I can use printing. Printing is this part. Right, create an array of size 5. The last character is feedback modulo 3 and then divide it by 3 to get the second last. This basically changes a decimal number, let's say, to a ternary representation. Every mask, I have ternary numbers like 0, 0, 0, 0, it means all green, and that's just 0. But if I have green, yellow, yellow, black, green, that would be like 2 times 3 plus 1 times 9 plus 1 times 27, something like this. We will test it in a moment to see if it works, but I'm not going to use this. Print guess, get value. That will be just in match. And I can remove this struct. Again, what I'm doing right now is just refactoring the code from yesterday. After I'm done, we will do some testing, some optimizing, and then we'll see. Read somewhere that it's going to take $80,000 to find the optimum tree at depth 4? Give me the source and tell me who will pay me. I think maybe somebody thought about a brute force and just estimated without any pruning how much time it will take. Yeah. I think I will turn off the YouTube chat. Sorry, YouTube users. But you can go, in the YouTube description there is a link to Twitch chat. Then it's turned off. Sorry, just there is too much spam and it's hard for me to follow anything with chats on both websites. Twitch chat alone is fine. Okay, I've done some changes already. Let's see if things work in the same way. Also, what was the time? Around 5 seconds, I think. Yeah, seems to be the same. Let's continue. We remember the feedback for every pair, I think, hidden comma guess. Oh, the printing isn't really tested by running it because I never print anything. And this is perfect match. Preprocessing. In preprocessing, I should also include the frequencies. So all of this moves to preprocessing. This is the main function. Let's for now minimize it. Sort by frequency. I mean sort dictionary by frequency. That will be the first part of pre-processing, or let's use more meaningful names. This will be count matches. This will be sort dictionary by frequency, and both of them should be used. Instead of one big function pre-processing. And print for now shouldn't be used. Yeah, there is match. All right. Create a map with frequency for every character. Then do this. So compute those frequencies by what? Return get frequency of a word A is greater than get frequency of word B, where get frequency is just a lambda function here. It's the sum of frequencies of characters inside. Count matches isn't really good name. Pre-process feedback. I don't know. Okay, those two are done. There is cache counter. What kind of counter was it? Counter of how many times I run the function. Later I will add back those statistics. Okay. Leaderboard. What do I submit here? Everybody has the same average. They start with different words though. Crane isn't the best word. Why are those averages 3.4 only? I see. So we work with this set of 2300 words, which is fine. Yes, I think it's a good idea for me to just try to win here. There is animation of $80,000 here. Okay, but that's just brute force. So this $80,000 is not that meaningful, but it's great that there is some leaderboard. Yes, I will submit my bot there once I'm done. Once I really solve this optimally. Maybe I should add this as to do. Point 10, submit my bot. Okay, refactoring continues. Saved. Let it stay. If this... Yeah, fine. What is happening here? Which is supposed to only consider some candidates. For now I'm not using it, so let's remove. This is whether already we achieved something. What happens after the end of this for loop? Some printing. Maybe this should be done with goto, even though goto is a terrible thing. This means that something was already done optimally. So here I don't want to continue. I remember that I added this at the end of the stream or even just after the stream, where always when I have some words, let's say the full dictionary size is 12,000, but I see now that possible words are like possible, there are like 100 of them. Then I first try all of them, because most likely one of them will be a good guess, but then I go through the rest, the 11,900. And here in some way I achieve it, this order. But if among those I already see something that is for sure optimal, which means that it breaks things into sets of size 1, and you cannot do better than that, then I don't continue. That was the idea. I'm not sure if it helps with speed. And as always, we can only improve the speed. The correctness is there. This finds the optimal strategy. Just it's too slow. Code is so much cleaner than last time I saw it. It shouldn't be. It's the same code. Yes, I was wearing glasses like not half a year ago. 4 months ago I did a LASIK surgery. Cache all info so far. All info so far, it gives me this set anyway, so whatever. The info so far boils down to what are possible words. Not possible. It's called impossible words. Here, not done. For every guess in the remaining or the impossible words. Where does this end here? This was a very hacky thing. I remember that this thing relies on the fact that the number of iterations in my program will not exceed int size. Int is up to 2 billion. After the stream, I wanted to run it for a night to run for like 2000 words in dictionary. And after an hour, I saw an assert failing that I overflew, that there was an overflow of int. Then I changed this to long, because my program does more than 2 billion operations. Actually, more than 2 billion calls of this function DFS and iterations here, but in fact the number of real operations is much smaller. Do you think you can score below the best average of 3.42? It's hard to say. It's hard to say. I'm sure that I can reach 3.42, just like they did, but we'll try to beat it. I'm happy that now it becomes an optimization problem. By the way, if you two upcoming contests that are also about optimization are Google Hashcode and Replayed Code Challenge. So if you want to participate in something similar, trying to write this code where it's not really that you have linear time complexity and can just solve it, but you keep improving it and finding better and better solution, or faster and faster solution, those two contests are something I recommend. Google Hashcode and Reply Code Challenge. Salad said that he proved it with an exhaustive research. Do you have any link to that? Then maybe Salad is the best. But I thought that we are aiming at 4.1 or so because we have 12,000 words. Indeed, if we have only 2,300 words, then it's a different story. I can add it. Only dictionary 12,000, but only 2,300 possible answers. That's how it works. So this is an exact strategy. Depending on what you get as a feedback, then what should be your next guess? Ukraine is worse by 0.004. Okay, but what is the source of all of this? Oh, I thought that this is a Wikipedia article, but this is just a block entry. So somebody already did what I'm doing. That's a very nice article. It describes a lot of thoughts I was having. The author is for sure a talented programmer. One day on one PC to prove it. How though? It's great though that there's already a written description. You can read this later on your own. Alpha beta pruning is basically used here. 600 lines. So I'm halfway there. It's sad that I'm doing something that already is done. And from when is it? 5 days ago. I'm 1 week too late. Ah, damn it. Okay, but I think then I will try to aim for exactly the same thing. The dictionary of allowed words is 12,000. The dictionary of possible answers is 2,300. And just today I need to refactor, optimize my code, and we should derive at the same solution, which basically means that I'm solving the same problem as this guy, and then it will be a comparison of answers. All right. I'm moving this to read in detail later. 2,300 words are relatively common. Yes, that's right. Okay, let's continue. One nice idea I've just read there in this Wikipedia-like article is that first you can run for only top 100 every time. Only try top 100. From this, get some limit for the answer, and then run again. But I don't know if that will be necessary. I will try to, in other ways, also improve my code. Said Crane was optimal. Well, first, he only used a heuristic. Second is he solved a different problem. I think he assumed that there is just dictionary of 12,000 words. And then the answer is 4 point something. Let's continue. Impossible words. Does this compile? Yes. Okay, there's EV. This ugly hack for finding if it's all single right now. Do I really need to do it this fast rather than put things in a set? Will that matter? One way to find out is to just run it for a set. So what if I insert all possible feedbacks to a set, and then all single just means that SS size is equal to remaining size. Is this slower? 5.5. It is slower, so I needed that improvement. The answer is the same, right? Yes, it is. Good to know that this is a possible bottleneck. If all single, then we stop here because this is the best. Here for every frequency and compute, for every guess I compute the frequency, and here map should be fine because for small groups I stop here at all single, but for bigger groups I do that. Where it shouldn't matter that much what I'm doing, I think. Or should I use an array of size 243? Do I sort it later? Almost. I sorted here. Oh, one more thing, one more improvement is if everything gives me the same feedback, then I can ignore this. So let's also compute small and big. And if they are equal, then this is not a good thing to consider. Can I just continue? Not sure. Oh, I do it here anyway. So it shouldn't affect the answer, but can only make the program faster. C or CPP? I think that CPP is more modern. Then here I can say assert false, because in my opinion this is impossible. I wasn't right. Frequency of info. But I'm checking this here. Out of all remaining, oh, I'm ignoring a perfect match. Why do I continue in this case then? Yes, I shouldn't do that. I think that this is just straight wrong. Then it's nice that I will be able to test my solution against something else. The answer didn't change, but in my opinion this wasn't right. I continue for a perfect match, so size 1, it means I'm matching something exactly, but everything else gives me the same feedback. It seems possible. Okay, the frequency for every feedback, and there are 3 to 5th power possible feedbacks. I want to know which remaining strings are possible. Now for everything here. Why do I change single false there? This is a better estimation. If I hit continue here, EV is destroyed? Yes, it is, because it's here. That's a big improvement. So often already from this estimation I get I can break. So I wonder if epsilon will help at all. Actually, I shouldn't use real values at all. Everything can be computed using integers. no, whatever. But if I'm not doing this here, then saved is not meaningful. For now, let's just erase saved. We sort frequencies by the size of this vector, so how big group it is. We start from small groups, there was a reason for that. But we can check what happens if we try in the other order. 3.2 versus 2.5, so this order is better? Maybe. Let's try a bigger dictionary. I'm trying to refactor things, but already I made the solution faster. Before continue, you'd also need to do ev is inf. Good point. I think you're right. Well, this actually, if ev is greater than best, I don't need to change it, only if ev is greater than need. But I think even with this, it doesn't matter. For now, I think I never need to do that. Because ev being greater than need, it anyway will send the information up that it's too high. So for now, let's continue with this version. Took 18 seconds versus now smaller than, greater than, it was 18 seconds. Up to 9 to 5. Okay, so greater than is a better version for big tests. Let's move this down. And it's also a better version for smaller tests. It used to be 5 seconds. Now, do I need this? I claim that it's not needed. 2.968 crate. Yes, so this is not needed at all because if we will... Oh, I know why I needed this. This is just needed for displaying purposes, to show a value that is maybe not computed correctly. So it's enough if I here say plus equal something. Just to show that it's a big fake value, not computed completely. S is just frequency, that's size. I don't need the variable. This means if this is not any kind of infinity value. Okay, good. Still a correct answer. We did some refactoring. I don't know if anything more is needed, but while thinking I can as well again run for half the dictionary. It used to be 4 minutes yesterday in the evening. I hope that it gets better now. Also, candidate ratio is not used right now. Right? Yes, that's right. What? I'm already streaming for an hour. You want to find a set of words that could win every time? No, the strategy is of course flexible. Based on the feedback, it will do something else. And I want to find the best strategy. Apparently now it just means to match what Alex1770 described on his website. I should get information at the end that optimal is solid. At least if we use the 2300 as possible answers. Which might be nicer for me because it will slightly improve the time complexity compared to the full 12,000. For 2300 I can already compute it in a few hours. Here it will be slightly more difficult because my possible guesses are 12,000. Okay, we got this down from 4 minutes to 1 minute 15 seconds. Also, it's bad that I'm using time instead of also measuring the memory, but that's fine. So I think already we can run this in maybe an hour, which is a great news. And 5 years got now down to 1 year. But it's still not a 1 day of CPU. I did refactoring. Now what about testing? I want to copy this code, remove all the improvements, so make it the slow basic solution that tries everything, and compare them on random small dictionaries. Stuff later was visibly slower. It's not the case anymore. I changed something to improve it. I don't know if it was about groups of small, if order of small groups or what, but it's now better. Now it, instead of 1 minute 15 seconds, it's 1 minute and 6 seconds. And 19 megabytes. But what about this? If maybe I shouldn't optimize here, but because instead I want to get to the end if I started. But I start from big groups. The point is, if I get to the end, then I put it in cache. No, it's visibly slower. Or is it? We'll see. This improvement is for sure very good, because this one, it just immediately avoids going down into some cases by just estimating using group size after the split. Yes, I think that this is a very, very good idea. Consider all the idea was consider all guesses, check group sizes, only then go recursive. So I can also, after doing this first part, I can sort by it. So sort by the biggest group, right? I want to split into smaller groups. Can use some heuristic for better order, better pruning. Oh, one more idea I had was that I first sort the full dictionary by frequencies, but then I can, once I have a smaller set of possible remaining words, I can again sort it by using frequencies of only words that are left. If I already know that E doesn't exist, then it's not a good idea to go in order from words with biggest frequency of E. Yeah, so this is much slower. From where are we getting the dictionary? Somewhere, even in the source code of Wordle, if you inspect the website, there is a dictionary. And somebody posted it online, so I just copied it. I have a list of 2,300 words that could be the answers, and 12,000 words that could be guessed, can be used as a guess. So time for testing. So this is visibly slower. Okay, now this is the real deal. How do I want to go about it? It will use some dictionary size. If I use 0, something strange should happen. Exactly. I think I want to here say this, and I will constantly do this for size 1%, which should be very, very fast. 5%. Why does it try only some starting words? When do I print? No, because others never get there because we break. No, I still go here. This is why, right? Whoa, so this is great news. With so many starting words, we very quickly eliminate them. Wait, no, I messed up. Or did I? Did I use runtime null? Yes, I did. I didn't want to do that. Now I can run it with a different seed to choose the dictionary. Dictionary size is always 1000. Wait, it shouldn't be 1000. When do I print the dictionary size? Here. 5% is already 1000? Something is wrong. I'm reading from into.txt with 2300 words. I say that I want 5% of it. And it says that dictionary, there is no new line. Those are actually 2 lines. Okay, now that makes more sense. Dictionary size is 115. And with different seed, it will choose a different dictionary, just always random 100 words. Now I can copy this to bruteforce.cpp, and I can remove all my improvements. The answer should be the same, and I will test those 2 solutions against each other. here for all the guesses among the dictionary. Simpler way of computing EVE. Now we are doing this step, the testing. I don't want anything here. Nothing. Now when do I continue? Because I don't want an infinite loop. If everything gives me the same info, then I didn't get any information. So in this single case, I should continue. No, 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 no. For everything in frequency, not inserted frequency. I don't want already. EV is here just one. It should be one because I'm making this guess, and here I'm adding the possibility what happens further, which is just this simple thing. I can remove caching. Done. We got down to 180 lines, and the point is that here we don't have all those improvements, but it should still give me the same answer. Now, is it too slow because it's slow, or is it an infinite loop? Let's try with a smaller dictionary. That's such a difference of speeds. So to really test it fast, I need to use just 1% of dictionary. Because for 2%, we need this versus, of course, the Wordle works in milliseconds. And even for bigger dictionary that was. Then I think that we already yesterday achieved, like for big tests for the full dictionary, 1000-fold, maybe billion-fold speed up. Now those two things should print the same stuff for dictionary of size 0.02. I don't want this file. Do they? Is dictionary size the same? No, 46. Why is that? Dictionary size 0.02? 0.02? .46. Maybe I need to recompile Wordle. Okay. Canoe and alter. That's suspicious. The answer is the same. So maybe the difference is just how the tie was decided. Let's see. Alter. 23913. Oh, that's bad news. According to the brute force, alter has a worse answer, but the final answer is the same. Maybe just best guess isn't computed correctly. So let's try a different seed. Siren at 2.32. Siren at 2.32. Here they agreed. Agent at 2.41. Again, the other value isn't correct. But the real answer is correct. Shire. Correct, but irate. This time they agree. Once I understand the issue and fix it, I will just automate this testing to try thousands of tests. But for now, I can as well analyze them one by one. Oh, this solution is so slow even for dictionary size 46. Now we can do 1000 in this time. Oh, 1000 takes 1 minute. Arise, arise. Strange. React, and the answer is different. One of my improvements isn't correct. Well, what now? I can, from the big program, remove some parts. I can also make sure that the dictionaries are the same. But if the word is the same, so in Wordle, one of my ifs apparently is wrong. I will try to get rid of them one by one, but some of them are very hard to comment out. There is this order of operations. I can replace it here with guessing all of them. And it's still the same. Control Z, Control Z. Well, brute force is more correct than my real solution, I think. Unless I messed something up when going through it and erasing unnecessary stuff. It doesn't use need. What do I do now? I can continue just doing things in a different way. What about this? Infos, insert info. And instead of all of that, let's do what I did there. Info size is 1, then this is bad. Don't consider this guess. No, still incorrect. Can we see your code somewhere? For now, let's say I can give you the brute force. I'm pasting it somewhere. Here you go. Pasted brute force to paste bin. Just for reference, it's this link. If somebody wants to retype it, you know, you can pause the video to do it. Well, I need to boil it down and understand what causes an issue. Not cache. Not the order of guesses. Maybe the expected value isn't computed correctly. Because right now I compute the expected value in a very strange way. My implementation of DFS is faulty. Well, my whole solution is DFS, so I guess you can say that. Okay, let's try to mimic the implementation, the computation of EV. Now it's garbage. No, I thought that I'm using already here. Now it's count. With this probability, go down there. Expected value starts as 1. That's good. I shouldn't do this. Okay, my way of computing expected value is wrong. At least it's not equivalent in those two cases. So what I commented out is not right. Let's see. This is, oh, I should subtract 1 only if it's 1 of remaining. Oh, that was fast. Control Z, Control Z, Control Z. So it's at least this. Should I do that? If this is the first run, then I try one of the existing words. Maybe let's here just put it as 2, unless in a moment I compare them. is perfect match, only then EV minus equal this, because we don't need a second guess in this single case. Okay, now it's the same. Let's try previous tests. Siren 2.32. Yes, Siren 2.32. That was already here. Shire 2.32. Arise. Now I will change this to automatic test, but for this I need to decrease the dictionary size even further. This slow solution is so slow. Pruning helps. Okay, now. Oh, because we are using 2%. Come on. Cannot have that much. But now dictionary size will be 23. That's not a lot. But I only want to see best guess chain. What if I do that? Let's comment out this part. Same in Wordle. They should always print the same thing, so let's test that. Wordle 11, brute 11. There are just two words with the same answer, which might happen. Let's try now without writing best guess. Hundreds of times I try a random dictionary with like 23 words, and I check if brute force agrees with the fast solution. Salad salute. What is even salad? Is it something in chemistry? Salad. A helmet. This kind of helmet is the best first guess. Chemistry is solid. Okay, I think this is what I remembered. Light Salami, can you stop spamming about hacking? This stream isn't about hacking. Even though what you see on the screen for sure seems like hacking. I told this story once, not really a story, in my streams. Well, normally I study, let's say, math or computer science. I'm in faculty where everybody knows what is math and what is computer science. But for 1 year I studied economics, and I had my laptop during classes and I did some coding because the class was boring. And my friend, more like colleague, told me later, "Oh, I see you're a hacker," because he saw, you know, this black screen with some white font. I told him that no, I'm just coding something, and he told me that this is exactly what a hacker would say. So you see, I'm a hacker. And he wasn't joking, sadly. It's not that he was sarcastic. Okay, testing done. What is next in our plans? Optimizing. Well, what do you want to optimize more? It's perfect, right? Printing statistics. Let's think about some optimizations. In particular, only recently okay, but is testing done enough that I can remove this? I know what. I'll make a directory for testing, and the two current codes, Wordle and the other one, I will move there. So if I ever need to get back to this, it's there. But then let's move back. I don't need this as an argument anymore. .5 seconds to handle dictionary of size 1/4 of that, so 600. Let's try to now run it just like the other guy did it. So there is dictionary of allowed words and dictionary of possible answers. What is a nice approach for that? Wait, those two files are the same size? 12,000, 2,300. I will read both, and then I still want to be able to only do things for part of the input. Also later I have the sorting. Do I need two vectors? One for dictionary and the other for remaining? Because this should use first only those from the file. Sort dictionary by frequency. Why do I sort it by frequency? To try it in this order. Where do I iterate over remaining? Well, here obviously, but as well there. And here I never stop. I could stop earlier. Yes, I can stop much earlier. Okay, this is a speed up opportunity. This was what, 2.3? Oh, I messed up. Only this one. What is this spam in the chat? How is your virtual machine so fast? Should it be slow? Yeah, it's a virtual machine. I use this. If it's not remote, then there is no reason for it to be slow. How long it takes to be in the top? Several years if you're lucky. I want to hear stop earlier, so I will add this as I go. First, is this correct? 2.99654. Okay. But now, if EV is greater or equal, I'm genius. That's twice faster. Whoa. Whoa. Now this should be a constant because just computing it might be slow. Division is slow for a computer. 1.2. No, that's just great. Let's try half the dictionary of size 2300. It used to be 4 minutes. Today we got a little over 1 minute. My compilation command, you will find it somewhere here. Chess engine? No. No. What I think is interesting is a poker bot. If I'm bored 1 week, I might try to do it. But I don't know theory behind it. I can play poker. I know rules for sure enough to implement the rules. But I don't know how this bot should look like. I'm very good at writing for loops and ifs, but I'm not really good at reinforced learning. I thought that I improved the speed and doesn't seem so. Whoa, now the bad words are very quick to for us to consider them. Strange. I thought that we improved this already to this. And now we have 38 megabytes, that's more. Trading bot? No, never. And my advice to you is also, don't try a trading bot. You're playing against companies who are experts at this, and they have very, very small latency. The odds for you to implement a good trading bot and run it yourself and win money in the long run, better than just buying S&P 500 and holding it, is like 0.01%. Maybe not that low, but still, you will just lose money and time. If you are a programmer, don't waste your time implementing a trading bot, just work. Poker bot though, that's interesting, in my opinion. I think I can do this here. I'm changing the order of doing the same set of things, just hoping that it might help. I need to decrease the dictionary size to make things faster. But now it is faster, right? I think so. I don't need to put things in a map to first make the estimation. From 77 seconds down to 23 seconds. 23 seconds, 37 megabytes. It's more memory than before. That's okay. We are already looking at the full dictionary of 2300 in less than an hour, so also the full dictionary of 12,000, even if all could be answers, I think in weeks at most. .8. It used to be 80 minutes. I will run. Then we'll see how it goes. We need to survive. What? Oh, you're talking about AI. I see. Creating SaaS before? It's like asking, did you think about programming? But what kind of SaaS? If I think about some product, I can consider this product. It's not that you start thinking, maybe I should create SaaS. AlphaGo program will soon include the line outer tourist at the top. That would be interesting. Is it already 10% done? This used to be 80 minutes. I think we did it. I think I don't need to improve the speed anymore. What about the memory? Memory is fine. So we were close yesterday. It was just about doing those optimizations a bit earlier in code. It would be nice to stop this even sooner. So like if EV plus minus single inverse already is great to big, minus absolute, oh whatever, break, am I right? And this was for have the dictionary. No, 77 seconds wasn't for half the dictionary, or was it? Yes, it was. 2.21521. 21521. Can we run this in parallel? Yes. We can. 21521, that's not right. But without it, it was okay. I don't see how it can mess things up. I'm going here. I can only see a single perfect match, I believe. And I'm saying this expected value, even if later I subtract inverse, if it's too big. Oh, but it might be temporarily low enough. EV plus equal, as always, we need to add something. Is it 10,000? Not that it should be consistent necessarily. Let's try now. All single is false here if I see that I again see a string with the same feedback. In this case, I hope that, like here, I will continue. Oh, but all single is first. It's checked first. I see. Is it okay if all single? This can still be done. My program slowed down. I think that it's also because of a mistake. Are we at 0.5? Yes. 21521 or something like that. It was. Yep, 14 seconds, even better. Was it for the full dictionary already? I think so, but I'm proving this more and more, which is a nice feeling. I made algo that computes rate optimal strategy at debugging. No. I'm trying like billions and billions of strategies to really find the best one. And it's all about making my search fast enough to run it for the full dictionary of 12,000 words. The full dictionary of allowed words is 12,973. Okay, what else? Go for remaining. For each of them, check the feedback. Swapping the order of those two dimensions would be better cache-wise. But is that enough to make this change? No, I don't think so. Free Blue and Brown updated the video and he knows something gets 3.43. Okay. I might decide to rerun this algorithm because I already got down from 23 seconds to 14 seconds on the lower tests. Now we have 15 seconds. 30 still around 37 megabytes. Let's try more. Should I not use cache for small groups? Remember that my scores here are not correct because I don't use the full dictionary. So if you see here 3.3 against 3.5, it's because I use fewer words. So this is worse. What about just this? I'm not beating anybody in the leaderboard. No, this was not a good idea. It seems that it's always good to use the map. Next, to decrease the memory, I can hash my vector a little bit. What's the easiest way to do that? But there might be issues with it. No, let's try. I need a big prime, or not necessarily a prime, plus x modulo 1,000,000,007. Unsigned long will be much better. Unsigned. I'm computing a hash. Basically, I'm creating a hash map. Well, I can just use a hash map. No need to implement it myself. Oh, maybe, I guess there is no hash of a vector, so I'm implementing this myself. Hash times this plus x modulo, or without modulo? Yeah, without modulo might be better. Just let's find a prime around this. Whenever I want to find a big prime, I just use factor in terminal to do that. And now I claim that I should use compact. Let's say hash modulo or hash, this will simply overflow, which is fine, comma hash shifted by 32. Can I do that? Narrowing, I'm aware. The memory should improve a lot. And the running time, I'm not sure, we'll see. DFS is some algo? Yes, my algorithm basically traverses a tree. It didn't help significantly. For bigger dictionaries, the difference will be bigger. But if it doesn't help a lot, it's not worth it, in my opinion, because it's a risk of messing things up. Even if it improved things by like, 5%, if I try 10 such improvements, I'm just too scared that something will be messed up. We are here like 60% through the full dictionary of size 2300. But let's look for more improvements. It might be better to here iterate it backwards. Nah, whatever. I expect that a lot of time things will be pruned thanks to that. If not, then here we have a slow version. Is it still faster this way? Depending on what I do, it might turn out that one order is better than the other. I can also try without sorting. Maybe that's the best. So this is slower. Well, not really slower, but there isn't any significant difference. Let's try both orders for bigger dictionary, like this. Where is this order thing? Where is my sort? Here. Greater than. Let's run. Should take a minute or so, maybe more. It's slightly too slow. Say 2/3. I thought that I'm not getting there today, but I think we are there. I will run during this stream the solution for the full dictionary, and it will not finish in time. It will not finish during the stream, but maybe it will take just like a week. I first might want to run things in parallel, because that's very easy to do. That will slash the running time by like 10. Next thing in my agenda, not printing stats, let's do that later. I want to read from dictionary of 13,000 or 12,000 possible guesses and 2,300 possible answers, because that's how Wordle works. This is how other guys did it, so I could compare my scores. I need to read 2 separate dictionaries. But then, how do we test it for half of it? I think I need to take a random half of dictionary of 12,000, and then out of possible answers I need to take out whatever is impossible. Then there is sorting. So I think I will sort both dictionary and answers according to the same thing. Recalculate char frequency and sort remaining. And then the caching wouldn't work, and because of that, it's not an easy fix. Yeah, this is almost done. I think we have like 1,500, maybe 1,600 words to analyze. We use smaller than what? The memory grew a lot, 180. How is my other solution doing? I think it slowed down. Okay, now for smaller, let's run again. For caching, I could use a bit set, but almost always, this vectory will be very short, and then using a long bit set of fixed size is a worse idea. Actually, I can use bit set of size 2000, not 13,000, so it should be fine, but I think that this isn't really a bottleneck, though we can check. Here's an easy way to check if this is a slow part or not. I can repeatedly say cache find remaining, and if compiler doesn't optimize that, by doing this, let's say 10 times, let's see if it slows my program down 10 times. If so, this is a bottleneck. If not, then that's not a bottleneck. This is how you can measure without any profiling if some part is very slow or not. I think it's now faster with smaller done. Let's wait for it to finish. What is the time complexity of my code? I think it's d to 7th power, where d is dictionary size. But also it's actually much better than that, thanks to pruning. Okay, it's now 84 seconds. and we did 66% of dictionary in 1 minute. Yep. What was I supposed to do next? Reading, I think. Oh no, the bottleneck testing. Should it be that slow? Oh, it's 15 seconds. So it should be. I don't know if it's D2 6 power, D2 7. It's very hard to analyze. 40 seconds. Okay, for testing purposes, let's get this down to 3. To 4. To make it just slightly faster. And it's with this or without 4.40. Like in any, let's say, backtracking, I did a lot of pruning. I don't really have 12,000 to 7th power, and I only ran it for dictionary of size 1000 or 2000. This is slightly faster. If I do this 50 times, I thought you need to use O. What is D? D is for dictionary size. Okay. If the program slows down by around 1 second, if I 50 times use access to a map unnecessarily, it means that out of my whole 4 seconds and something, using this once takes like 10 milliseconds. So it's few percent of running time of my program, so it's not worth optimizing. Now, this takes a lot of time, so let them race. I'm running for full dictionary, which I first estimated as 4 hours. That was yesterday in the evening, but now it should be much faster. And some time ago I've run it here, I don't know, 20 minutes ago or so. But now I think this current version is so much faster that it should beat it. Reading. I want to read both dictionary and the remaining. If dictionary contains it, then push back to possible answers. Thanks to this, I can still remove half the dictionary at random. And I can use this. Set dictionary, what do you want? Yep, and now sorting. Sorting is messed up. And I need to pass only indices of those. I think that's it. Find, there is no find. No, this is possible. On possible answers. Actually, from the very beginning, this should be a set. So here, possible answers is a set. Insert. Like that. Let's print dict size and init size. Obviously only running it for a small part. Makes sense. Okay. I'm running the real thing, the program that I want to eventually use. For now, 1300 possible guesses at all and 200 something candidates for the answer. 1/4 of the input. Why does it do things in this order? Eight seconds. That was fast, but why this jump? Is it because it first considers common words and then uncommon words? Or there is something repeated here? One 1114. 11114. Oh yeah, because I first consider all those that are allowed. Yes, this is the intended behavior. That's actually fine. So 1/4 of dictionary is 9 seconds. I guess I want to use this. To also know what memory I'm using. 37 megabytes. Okay, let's continue. 35. 0.4. It will be too slow, right? Doesn't seem to be very slow. But now it needs to kind of reset. Oh, those are big numbers. But it isn't slow. We might see the answer today during the stream. How much time it takes to double the dictionary size? It used to be like times 60. 5 seconds versus 4 minutes. Not waiting 5 years is very cool indeed. I might implement running it in parallel, yes. Zero 0.4 is 61 seconds, so just 1 minute, and 109 megabytes. What comes next is half the dictionary size. This was times 7 almost, let's say times 6. So the question is 4 divided by 2.5, that's like plus 60%. So 1.6 to what power is equal 60 over 9. I'm interested in this, and this will tell us how much slower the algorithm gets when we double the size. Why? I cannot type log. Four. And what did I compute? That the time complexity seemed to be around d to 4th power, judging from this. So times 2 should give me 4th power, time should be times 16. Then I'm estimating that 0.5 will take us 9 times 16, around 150 seconds. I should see here 150. This was done. What did we compute here? In this amount, in this time, which is half an hour, in 30 minutes we computed that the best guess for only a set of 2300 words is crane. But this number is too low. Oh, it wasn't full. It was 0.8, I think. Oh, damn it. I see here some number which is not the same. Well, that's bad. First, 1850 divided by the number of numbers here. What is that? 2315. Yes, that's 80%. That's bad, but this number was from before I made some correction. So we might be okay. Now I claim this is still crane, but with this score. $770 megabytes. I said 150, but actually it's 180 seconds. That's fine. For half the dictionary of possible words and the possible answers, I solved it in 3 minutes and around 200 megabytes. This now we need to multiply by 16. That's 50 minutes. It will take me 1 hour and a lot of memory. Actually, not that much memory. Should we run it? Or should I test first? That's a difficult question. I'm not really interested in that anymore. I think I just want to run it. I can always kill this. 13,000 words in the dictionary, 2,300 possible answers. Let's go. Did he discuss suboptimal parts in 3 blue 1 brown heuristic solution? Not too much. His solution is heuristic, so it doesn't need to be optimal. Yay, first word computed. And I can check it. I can already check it. Because you guys gave me a link. Those should be ignored. It just means that they are worse. Arrows. Yes, yes, it's exactly right. 3.4605, I confirm that. Oof. That was a lot of work. So today 2 hours and a half, yesterday 4 hours. Plus some thinking between streams, it was 7 hours of work. This will finish in 1 hour. Whenever we see a number which is not huge, it just means that it was computed until the end. So those values I claim are exactly right. Such a nice thinking, such a nice feeling. I really thought that today I will not finish, because yesterday in the evening I thought that I'm too far away. Okay, what else is here computed exactly? Stale. 4415. Yes. List. Oh, that's hard mode. I'm not interested in that. Four, 3, 5, 9. Yes. Oof. Salad. Do we already have salad here? We have slata. What about Rust? No. I can make my solution even faster by forcing it to start from salad. Oh no. Salad isn't among possible real answers. So my program will go through all 2000 words first from this list, and only then it will go to this list. So it will take some time to find salad. I'm not going through them in dictionary order, but we can cheat. And that's not real cheating, it's just for speed. I think in dictionary so when sorting dictionary by frequency, because if we consider salad first, then very quickly we will get faster computations. We got to 388 in 300 seconds. It even takes a lot of time to pre-process the matches. I sorted by character frequency, but anyway I force my program to first consider... Oh, so the hack I did now is not enough. My program anyway first considers this. Considers the list of words not from the possible guesses. So this is still not salad. How do I fix that? In my DFS. Arrows. Now it should consider words sorted by frequency, starting from salad. Yeah, I could merge them, Gupta, you're right, but there was some speed reason I did it in this way. 42177, yes. I got it. I got the optimal strategy. I mean, I haven't yet proved it. We need to wait for 1 hour for this to happen. Did I slow down my program? And I think that now iris is one of those bad words. Iris. Exactly. So now it goes through everything, starting from salad. Which is not fun because we are not seeing right answers. The article in your browser also has optimal strategy? Yes. I think that for the first few words I want to see the real score. I wonder what's the way to achieve that. I guess I will just not put salad first. And as well, let's make this improvement. If EV is greater than 30, then let's print skipped. Otherwise that, can I do that? Can ternary operator this to string. Where's my salad? Just to see the results faster. Yep, that's exactly what I want to see. Yes, some of the good words are not possible answers, because your first guess, you are so unlikely to hit one of the words from the dictionary, like 1 over 2000, and it's more important that it splits the words nicely. In particular, it's easy to imagine that the very best word would be just something like RETAS. Maybe this word doesn't exist, but it hits very common characters and common positions. So this, I can even check that later. For various words, what are their probabilities? Okay, let's check. SOR. Yes. Errors. No errors. No, because it has a bad score. Arrows. Yep. By the way, I was going to here in this puzzle today follow exactly the strategy provided by my algorithm, but it would be more coding, you know, to force that those are the 3 words I already took. So let's just try to win this. Crane. Train. Oh no, T is forbidden. Brain. N is forbidden. Break. Not that. Drake. Frake. Praise. That's praz. Ura. Kra. K is not here. How is the algorithm doing? It got to a series of new words. Let's see. If something here has a nice score, it should be also on the website around 3.45. So all of those. Let's check. Taser. Wrist. Not in hard mode. 4 to 5. Yes. Earst. Yes. Terrace. That's, I guess, hard mode. Yes, that's hard mode. It doesn't qualify for top 100 in the other type. Stare. Yep. Oof, so it seems that everything is working. It will, I guess in a moment it will get to salad. I'm considering words in order of sum of frequency of characters. For now, the best found was wrist, which is here top 2, which is a good thing because thanks to that now a lot of things will be skipped and will be considered salad. Hooray! Whoa, those are very fast because they are similar to salad, just reordered characters. Yep. Now, this should run for an hour. Oh, I didn't win the game, right? This should run for an hour. I want to see the final verdict, salad space the answer. And then I can print more statistics about it, but I think I will put it in a YouTube video. Around tomorrow, I'm going to make a video on it. It can be a lot of work because I should prepare some visualizations. But damn it, I'm not the first. At least you experienced with me creating it. Also, at the end, we are only at 300 lines of code. And some of that are comments. So it was all about proper pruning, like I did yesterday, just doing it even earlier in code. erase. Erase would here display green on the first position. I'm not solving hard Wordle, but it wouldn't be difficult to change. Also in my code I can change it to penalize a lot for 6 guesses or for 5 guesses. Like if I have a choice, so first maximize the number of such cases where 3 guesses is enough, or 4 guesses, or and so on, and only then, in case of ties, maximize the average or minimize. I don't know, maybe that's a word. What is here? I should already change my program to allow for this, to say what are possibilities, what possibilities are left. Actually, I can do that. Why not? But I need to now change from this format of green and yellow to my hashes. $100 words out of 1,000, so 1% of the work is done. But it took several minutes. Something is wrong with my estimations? When did I start it? Let's remember that it's now 1938. Now I can scroll up and see. In a few minutes we'll see to just estimate how fast it will be. Maybe first few words are slow and then it's much faster. I want to tell my program what I already tried, and the program will tell me what is possible, what is left. Also, what is the best choice and what is the average. There is much. I think I can make a separate function. Get hash. No. Crane. And how can I describe it? I think it will be easiest to describe like this: black, green, green, black, green. Ghost, all black. Elder, yellow, black, 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 yellow. Break. This gets a string. Black means none. Yellow means any or something like that. Finally, green means exact. It's not any, so what is it? Yellow. I called it yellow. Scale this to dictionary with inputs containing words of n length. Yes, but I used number 5 a lot in my code, so it would be annoying. I wanted to check the time. This was 5 minutes ago, and we did almost 100. So let's say 100 in 6 minutes times, but I want 10,000. Then 600 minutes. We might need 10 hours. 1 hour wasn't a good estimation then. Memory should be fine. It's not interesting though now, it will just skip. We run it just for the sake of having a proof of correctness. I can also later modify it to never skip for the first 50 words, to really have answers for them, or to print answers for words with up to 3.5 and always use that limitation, skip everything else. Could be faster in parallel. That's right, that's right. I might do that. I think I will hard code the need of 3.5 and to run it in parallel. I will want to find all the words with 3.5 in parallel. But the memory can be an issue. Printing doesn't affect it, no, because I don't print a lot. Let it run for now. Maybe it will speed up. We're at this time. The feedback, the preprocess feedback is very slow. Can I make it faster? That is 11 seconds. Let's improve it. Exists of hidden. Here, and then I always can just check. Oh, I need to subtract, so I need to have a counter. Then let's make it a frequency. It's easy to mess something up here. Increase the frequency. If frequency of A of I, no, frequency of guess of I. What? Well, I am aware. Did I make it faster or not? Oh, just a little bit faster. That's fine, good enough. In 8 seconds I pre-process all the pairs. Then I compute the hashes. How is the program doing? In another 4 minutes it did 100. So I think it's getting faster and faster with uncommon words. It will quickly get rid of those. Yeah. The average is this, but what is the full range? I would need to add something to my code to give me this statistic. Now it did 3% of all the words so far. For this, I think I need to iterate over possible answers. And if much of this possible answer, comma, my guess, is not what I computed, if it is what I computed, then new possible. What is possible answers? A set, not a vector. Okay, then this program, if I didn't mess up, should tell me what is possible here after those 4 guesses I provided. Frame. The only possibility is frame. Thank you, program. Okay, that's nice. Next thing is, let's say that I only guessed crane and ghost. This 8 seconds of preprocessing is annoying, so I might want to optimize this even further. 5 words were possible. and the best guess is Drake. Why did it print only 4? Because I stop when I see that continuation doesn't make sense. So Drake is such a word. No. Wait. That it almost allows to distinguish. Why am I seeing only 4 words here? Oh, wait, no, I don't skip, do I? So Drake is here good, but surprisingly, it's also good to go with asked, slightly worse, but asked allows you to distinguish between them nicely. You never print frame, but this is description of good first moves I found. I just need to understand why I hit continue not to consider something. But this doesn't mean that I didn't consider frame to be the first guess. Let's see in the FS, what do I skip? So when do I hit break? Do I use done? Yes, here. We can do this, and then it will be full. No? Why? How are we doing? 5% of dictionary done in the full program. 1 hour is not enough. But 10 hours are. I think I will add running this in parallel, assuming that memory is good enough. Yes, it is. So I might need to decrease the memory by, again, hashing the vector. And then after that, I can run in parallel, always saying, give me all the scores smaller than 3.5. Or even, I can even not do that. When do I not get here? In this case, and in this case. Since we consider all possible scenarios, this means that the game can be adaptive. If something can be malicious, like always go to the biggest group, then indeed it would affect us. Best guess is Drake, and the answer is I think 2. So this time we considered all of them. Here we go, reads 2.6, then a lot of skipped values. We also skip if it doesn't distinguish at all. Spade 2.4. Let's see frame, how good it is to now play with frame. Why? Frame is not considered at all? Why is frame not here? Don't tell me that for frame this happens. Brains dictionary of guess. Hydrate, thank you. So frame is skipped because it doesn't distinguish. I see, because of this break. So because of this improvement, sometimes expected value becomes infinity because we see this is not a good guess, but because of that we don't finish this for loop and we incorrectly think that we have just one possible feedback. If I do this, we should see a frame there. From Ash. Yeah. So now we see that frame was skipped. Simply. Skip, it means that while computing the score for it, we realize that it's not good enough. Yep. Now let's get back here. How are we doing? 600 words are considered. After guessing crane and ghost, we should go with Drake, because that gives us 2.0. What about just saying crane? What is a good second word? Oh, but it then depends on the feedback. But if you guess crane and you get green, 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 the best second word is, ladies and gentlemen, dimps, with this average remaining score. So it doesn't count that first guess. Dimps. Why dimps? Oh, I see why. Because we want to hit many, many other characters. We don't care that R, A, E are already here. Then it means that it's very important to try things not among the possible answers, that's curious. So maybe we shouldn't prioritize guessing one of remaining words. I guess that it makes sense when we are looking at a very small group. But for big groups, I would say that first we should guess one of impossible words. If you insert dims as second word, you will get frame. Okay, now what about guessing crane and then saying black, 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 black? Exactly what Gupta said. Most words having something RA something E can be distinguished between each other using dims. If you guess crane and then you get nothing there, good second word is sloth with this score. I guess almost always two first words should be very, very different. So what now? Now let's run this in parallel. Okay. Before that, for smaller dictionary, say 1/4. It should take 9 seconds because I see that in my notes here. This is on the full dictionary. And my experimentation with crane was also in a full dictionary. 9 seconds, yeah, around 9 seconds. Gupta, I don't agree that non-BBBBB shouldn't affect much, because getting a particular pattern, like with a single arrow or something like that, it splits the space a lot. I think that still all B's might be the biggest space, almost always. This is why it makes sense to guess all common characters. – 37 megabytes, that's right. But I don't want to use hashing, because then this program will not be correct anymore, it will be random. Damn it, I need more memory, don't I? But running things in parallel doesn't use cache that well. Yes, I will make a video. Why hashing makes it bad? Because hashing can have collisions. I can create such hashing that it's okay even with collisions. No, it's tricky. Maybe it's okay not to hash big elements. So what about this? Only if remaining size is small. 37 megabytes and 9 seconds, or 8 seconds it was. This is for 1/4 of the dictionary. If I get a black on letter, yes, I remove all words with that letter, just automatically it happens. I don't need to add some extra code for it. Maybe this improves the memory. I should use a define for size. Whatever. Okay, the memory didn't change. Defines are just bad. Slightly slower, slightly more memory, slightly less memory. Yeah, it's not worth it. If I don't divide the memory by like 10, it is not worth it. What if I don't do it at all? I still put things in the map, but I don't look up the map. Maybe cache isn't that useful after all. But for bigger dictionary it might be more needed, but without cache I can run this in parallel easily. Now I'm not putting things in cache, so the memory should decrease. It did decrease. Let's try this for half the dictionary. It was 3 minutes earlier, so let's try 0.4. Used to be 110 megabytes and 1 minute. If it's still like 1 minute and a half, it's worth it running in parallel without any cache. What is your current problem? I'm going to run my program in parallel. I'm already done with optimizations. I've actually run it for the full dictionary of 13,000 words, and it went through first almost 1,000 of them, and I hope that it will be faster at the end. And I've run it around an hour ago, so it should need 10 hours or so. Tomorrow in the morning I will see it done. Here we are comparing it with 1 minute. Can I use 12 cores easily? And do I have some script for parallel running? I don't think so. Or maybe somewhere. Let's search. Here we go. Okay, I have already some tools for parallel running. That's good, that's good. Up from 1 minute to 2 minutes if I don't use cache. Also, cache is useful. But if I go for only some subset of words, the memory will not grow that much. This program went through 1000 words and the memory didn't exceed maybe 1 gigabyte. Those are my tools from Google CodeGem or competition like that, maybe Facebook Hacker Cup. Space-time trade-off, exactly. Small vector uses a lot of memory, right? Yes, both memory and time. Whenever something uses a lot of memory, it's also time. But 2 times slower, that's bad. And I really don't want to use hashing to make collisions happen, because then it's not anymore a correct program. Okay, I will just use cache, and it's okay that memory will grow. I will run such a small number of instances that it will not be an issue. Okay, so running things in parallel. First of all, I need to copy this. Actually, all of it. This is based on possible answer size. So this will be my range, number of spaces. Check if this is my job. And run the test case. So this means try this as the first string. Because this counts things from 1, I should do this. Now this is a range of IDs such that I am responsible for them. Should I go with dictionary size? And this is just for the first guess, because everything else you can do whatever you want. Dictionary is sorted here alphabetically, right? Right. Oh, I know, this will be easier. Try a first one only if its ID modulo the number of cars is equal to my ID. Yep, that will be much better. Prep parallel. Actually, most of that is not needed, but I need to pass my ID in cars. Just this. And they can be global variables. Where are you? For every guess, if as simple as that. Good. Now let's try smaller dictionary. And this should still be the same. So let's run it for 25 seconds. That was like 9 seconds. No difference there. It covers everything. Unordered map, I don't think it will help a lot, but I can try. Okay, now 8 seconds, slate, 0 out of 2. Now I think it does only even IDs. Crate 3.01. Crate 3.01. Crate 3.01. And slate. Good, I think it does the job. So we have our parallel running. I just need to use this script in some way. What does it do? In case of Control-C, it kills everything. In, out. I don't really need in and out. I just need the number of cars. Don't use more than 16. Sure. There is no input. And let's say it just should go. that was fast. I think my program name is Wordle. And the last line is something I want to see from both of them. So stuff in between you can print CRR, but the real thing with best guess I want to see in the output. And then we are doing that and copying to this file. But what is Z? Line 17 is wrong. Oh, I used A again instead of Wordle. Come on. Did I compile? Okay, a lot of stuff, great. But at the end, yes. They both will tell me out of this even versus odd ID what is the best. This is 5 seconds. Let's try 6 notes. 2 seconds. And now, of course, I would need to combine that. But now, the best way for now to do 0.4, that was 1 minute. Let's try it with 6 notes. I'm not dying. CPU is working nicely. So from 1 minute we will get down to 18 seconds. 1/3. Could be better, but there is reading at the beginning, there is cache. The total work time was 1 minute and 40 seconds, but it's done in parallel. And right now, with my eyes, I need to choose the best option. Now, with how many nodes do we want to do this? I want better visualization. Even more space, please. Now what with every column is a single node. So this one got to 1700. They all need to get to the very end. We nicely see the progress. I guess it's better to display the percentage. Yes, divided by dictionary size times 100. And for now, let's cut everything else. Am I running just for 2? Yes, I'm running just for 2. 8 nodes. They are at 30%. 70%. I hear my computer getting louder. Okay, 60 minutes and done. Five. Previously for 5 we had 3 minutes. Now let's try 8 nodes, and later I will try, no, I will not go higher, maybe 10. 10 is tempting, but also I'm observing the memory because it keeps growing and it grows very fast. 3.75 gigabytes. This node is doing much worse. I wonder why. Maybe it's about getting lucky first to hit something very good, to have a good limitation for the answer. So this one is far away. Oh, I didn't observe the memory usage. That's fine. 46 seconds instead of 3 minutes. Okay, I guess. Now, if I use at the very beginning the need of 3.2, is that faster? Now I've run it, but first I plugged the value that I know is close to being the best, 3.2. I could use this one, it would be even faster. Some nodes will now not find the answer at all, and they should print something like infinity. I'm curious in knowing if it affects this total time. But still, some nodes are lagging behind. Memory command 2. I don't know if it works like that, but let's try. A different set of nodes is now worse. Oh, because it didn't get to the end of any single node. I understand. But it seems that it's only worse. Why is it worse? It slowed down a lot because it didn't compute everything at first. Now it has worse limitations, or less stuff is in cache. Oh, we are 10% done. So yes, 10 hours. Without running in parallel, it's 10 hours. Come on, come on, come on, come on. There was a clear distinction here between 3 nodes that got very unlucky versus the other 5 got lucky for some reason. That might be worth analyzing. And those are extremely slow now. $10 hours. What is 10 hours? It's the time I estimated this program to run. Interesting. So the answers are the same. Everything is fine. If something if something is above 3.2, then it doesn't count. So those few programs that didn't finish with anything They are worse. Why? Because of the best. I sometimes compare only with best and not with need. Yep, here I should use mean of best and need. Let's see. Here we go. I wonder if this is just a huge skip in general, huge speed up. As recursively, I only passed information about best, not about need, even though need might be very useful. We are getting things down from 46 seconds to oh, not a big difference. But now, does it matter if I provide this 3.2 or not? I don't think so. Very quickly, they all find something similar to that. Oh, I was going to try the command, but I don't know if it works. Command time. Try using an ordered map. I would need to implement a hash. $16, so that's okay. R is some unrelated value. What I want is a real time. That E lowercase e. .55, 2.5. Okay, so that's fine. I can remove this because that's unnecessary. And now the question is memory displayed properly? It says 27 megabytes. Let's try here. 3.1. From 3.1 to 6.8, so 700 megabytes. 700, 800. Can't understand what is going on. I am running my program in parallel, making sure that, for example, memory doesn't crash. Just experimenting for now. Here what you're seeing is my program being run. Every column corresponds to one node. They all print how much they are done. 100 megabytes. That's not it. In total, 1 gigabyte was used. Oh, yeah. So this command doesn't work properly. Maybe it gives information about a single node. But the time is 1 minute. And that was half. We cut this down to 1 minute. Okay, is it time to risk it? I think so. Let's see if the printing is fine. Whoa, not 7, 0.7. And I'm going to use 6 nodes. Can we even understand anything here? Asir got this time, Rise got this time, this score I mean, and so on. This is skipped. Maybe if something is skipped, there is no reason to print it. And what's our memory? No, I'm not searching QQQ. How do I exit? One gigabyte and growing. Maybe I should not run all programs in parallel. Yeah, maybe I should clear their cache from time to time. Am I wearing contact lenses? No. I did eye surgery. Yes, I will leave this over tonight. This is why I want to make sure that it will not crash. As you can see, for 70% of dictionary, now it did 1/4 of the job. We are at 21% for this node, 19% for this node, and so on. I think that's fine. Maybe what I should do is, if cache is greater or equal than this, then clear the cache. I wonder what here is the cache size at the end. If I had shared memory, but I'm not doing that. Okay, now why? this should survive. Now for some smaller test, let's run it for like 2 cores or so. How often do we have clears? Just from time to time. It's dangerous what I'm doing here. I rely on cache a lot. I don't like it that much, but well. To make it more visible, I will do this. And now what I hope will happen is from time to time cache will be cleared. Also, if no, that shouldn't matter. 100,000 seems to be a reasonable value. What would be better is just the sum of cache size. Is there a function that tells me how much memory the map takes? That's not it. Let this run to the end, and then I'm just running the whole thing. Let's test this new hack of mine. We have the dictionary. When cache size is huge, I'm going to just completely clear it. That's my fix. Because I'm just worried if something runs for many hours, it will only grow. But from time to time, I want it to reset. I understand that it will slow the program down. So do this. And when adding something to cache size plus equal remaining dot size. Now this should clear a lot, I think. Doesn't clear at all, so maybe I can do this. $50,000. 100,000, 200,000, 500,000, and then after some time it should get down 800,000. Yes, and there was some clearing there. So this is reasonable frequency, but I want this to happen less frequently. 1 GB per item should be okay. I have integers here. Could even be shorts. This is a big deal, so I'm going to change it. No, it's too complicated. But I can almost have the memory size. Good, good. Now this was 70%, do I remember correctly? Of the dictionary with 6 nodes. And it took 10 minutes. I think it's 400 megabytes per node. Let's try. If the stream ends, it means that my computer just froze. Six or 8, chat. I don't think that size of will give me that. Tough typing, I see, analyzed the memory usage. 200 megabytes, 1 gigabyte. I think it's more difficult than that to analyze the memory usage, and we cannot extrapolate like that. And if we see from estimations that my 10 nodes should take 10 gigabytes, I'm scared to leave it. Double it? What, double the number of nodes? No, no, no. The virtual machine has only 12 nodes, and also it has this slow thing. Should I kill it? It did 10%. Yeah. 10% in 1 hour. It's hour something. So it should take, and it took 1 gigabyte. And it would keep growing a little bit, but only a little bit. Okay, then with this limit of 50 million, we should be fine, right? Also, we should do it at the end, not here. That many integers would straight be 200 megabytes, but there is a big constant factor. 30. Let's go. All the programs in parallel, they need 8 seconds or so to compute all the connections, and then they will start going. Ten nodes for now. The basic usage here is around 2 gigabytes, so it's already 3.3. Do we have raise? Yes, raise at 3.4618. Where is it? 4618, yes. Only the VM should freeze? I think so. I hope. assuming that the program doesn't slow down when analyzing the end, and that might be true, it might slow down, then we're good here. I think we were looking at like 2 hours of work, or it would be 10 hours without running it in parallel. 4 hours today, 4 hours of stream yesterday. Now I see that it's already 4 hours today, but we did it. I will make a video on YouTube on the main channel about it. And for today, I think this is it. Do we have a lot of viewers, by the way? Yes, almost 200. I mean, 200 if we count both YouTube and Twitch. Hello everybody, thank you for watching. That sounded like already saying bye, because I always say thank you for watching at the end. I want to say I'm grateful that you're watching this content. Now the first node did 2% of its job. This node is lagging behind, less than 1%. When we say skip, it shouldn't even say the word name, because it's just obfuscates the view. But I will not erase it now. I will. That's a little difference. And it grows. It already grew 200 megabytes. I wonder what is the cache size right now, so how far it will go. You've been waiting for streams. But aren't there a lot of Codeforces streamers? Like even tourist streams from time to time. I think we still have much more content than ever before, YouTube and stream wise. I want to verify one thing. If I here say like, let's say 30,000, then almost always it should clear. That's the thing. And also I don't even want to say skip. I will increase the fan speed for my computer. So I already hear it loud. We have a lot of clearing, and now the memory should stay at this level. Yep. So, and that would be very slow because I'm not using cache. Then, if I use, let's say, 300,000, how does it look? I think this is a nice way to estimate the memory, because we will see how high it goes from the basic. Up to this point, it just took some space to store the two-dimensional array of connections. Now, how long does it go without clearing? Already we got here 0.05 extra, and some things are getting cleared. So now it will, it should level around this level of 5.30 something. Node 6, node 4, 1, 9, 0, 2, 7, they all cleared. Then we shouldn't go above this value. Is it okay to do 100 times more? If this was 0.1 gigabytes, 100 times more should be 10 gigabytes. Then yes, that should be fine. So I can sleep and not worry too much about this. Once again, do that. We have a full dictionary, yes. I don't know if I compiled. Compile, run. Oof. 350 lines, which is not a lot. I think it will go at most up to 15 gigabytes. Which makes sense because I estimated this as this times integer, that's straight 120 megabytes. So 1.2 gigabytes if we count all the nodes, but times several because a map has a big overhead. The vector as well has a big overhead. Maybe changing capacity of a vector would help before putting in a map. But I hope we will not exceed the memory. So let it go for 2 hours. I will let you know in some way. How can I say? Okay, in YouTube comments below this YouTube video, tomorrow in the morning I will confirm, or maybe even today in the evening, how is it going. So in like 2 hours from now, I will put a comment saying how is the situation for all the nodes. And I will confirm once this is done, because then it will be a proof that everything works. I need to now read that whole article about the other guy who achieved the same thing, compare them, and I will just make a video on the main channel about this, trying to describe the algorithm and the speedups I did, which is difficult because on the main channel I often try to make things for everybody to understand, and this wasn't really beginner friendly. You can stop a thread if the memory exceeds a value, but that would still mean game over. I'm not saving any values. Okay, guys and girls. 4 hours. I wanted to do it today only for 2 hours. What can you do? But that's something that a lot of people are surprised about. That I or other people like me who are very much into competitive programming can focus for multiple hours. I didn't even stand up during this stream because I forgot about it. I forgot about stretching, just being healthy, because I got very much into this coding session. And I didn't feel tired even for a moment. If you like something and it interests you, this is how you will feel. It also helped that actually I improved my solution a lot today. Otherwise I would feel frustrated or disappointed. A little bit at least. I hope that this node, even though it's 0.8% now, it's not that for the whole time it will be 2 times slower than other nodes, because it then doesn't matter how quickly this one finishes, if this one will always be behind. Ten cores working. it's about time to finish the stream. Once again, thank you everybody for watching. Go to YouTube comments today in 2 hours and maybe in around 12 hours. You should expect some comments from me there with update on how is it going and whether the program finished without crashing. And I'll see you all in few days, I think, in the video on the main channel. Is there anything else? Check out the Discord server. Discord. And paid classes, richter.com. Bye.